So in this problem, we were given a binary string and we had to do k operations. In one operation, we had to replace every one in the string with 0, and we had to replace a 0 with 1 only if it has a neighboring element 1. Then we had to find out our answer, like what our string would look like after k operations. So to solve this problem, we have to look upon some observations. So they are like, if this string was like this, and we can see that this one will become 0 in the next move, and the neighboring 0 will become 1, and in the next move this 0 will become 1 because it has a neighboring 1. So if 1 and 0 are the neighbors, then they will start flipping alternately. But if we take this 0, the 0 won't start flipping in every move because it don't have a 1 near it which can flip it. But after the second move, we have got 1 here, so it will start flipping because same as these two started flipping. Like the 0 was will remain 0 till here, and now this 1 is besides the 0, so it will become 1, and the next time it will become 0, and next time it will become 1. So the bit this element will start flipping. But let's get to the next example. If the string was like this, the 0 and 1 are the neighboring elements, so they will start flipping from the first move itself. But if we talk about this one won't flip in the first move. This one would flip in the first move, but then it won't flip in the second move, because after one move the string would look like 1 0 0 0 0 0 1, and now the string becomes something like this. So these zeros won't flip in the next turns, but after some number of turns these 0 will start flipping again. Like this 0 would start flipping after this 0 would start flipping after this, and this 0 would start flipping right this one. So it will start, because 1 and 0 are neighboring elements, they will start flipping from the first move itself. So what if our example was this one, the string was this. So the 0, because I don't have a neighboring element 1, so it will remain 0. So in the next move this one will flip to 0, this one will flip to 0, this one will flip to 0, because 0 and 1 are the neighboring elements, they will start flipping from the first move itself. But what about this 0? This 0 will start flipping, which will start flipping from the second move onwards, because in the first move this one will transfer to this, and we've got a 1 besides this 0, so it will start flipping now. Because this is 1 and 0, it will start flipping infinitely from this move onwards. So what about this 0? The 0 will have to wait for 2 turns, and then it will start flipping. So in one operation this 1 will come here, and this bit will start flipping. In the third move, in the second move, this bit will come here and this bit will start flipping, and in the third move this bit will start flipping. So for this bit to start flipping we'll need at least 3 moves. But what if the string is all zeros? So it will remain same. What if it's 1? So we are given that k is at least 1, so it will become 0, and after that it will remain 0. So in so what if we have to generalize this? We can say that a 0, every element will start flipping after some k number of moves. If it's like a 1 and it has a neighboring 0, it will start flipping from here itself. But if if it's a 0 and its neighboring elements is uh, some x distance from it, so it will start alternating after, it will start flipping after x number of moves. Now we can just move to the code and see what exactly is happening. So we are in the VS Code. What we have done here is we have taken the inputs n and k, which is n is the size of string and k is the number of moves we have to do, s is the string, We've taken a vector v which will store how many moves we need, such that after that number of moves the element will start flipping 0 to 1, 1 to 0. Initially we'll calculate the count 0 and count 1, the number of zeros and the number of ones in the string. So we'll start with the base case. If count of 0 is double equal to 0, then we can print the string as such. But because if count is of 0 is 0, sorry, the count of 0 is 0, it means all the strings are 1, all the elements are 1. So we can flip them to 0 and just print it like that. But if the count 0 is double equal to n, it means that all the elements are 0, then we can print the string as such, because it won't flip. Now if there are a few number of ones and there are more than there there is some count of ones and some count of zeros, then for that case we'll do this thing. We'll find the closest one to every zero, which is just one more thing which I need to tell is, for this case we can just do like this 0 is one distance from it, which I mean the 0 and 1 have one element in between, so we'll need at least one move after which it will start flipping. So till one move it won't flip. But if the case is like this, what we can do is we can just do one move and we can make the string in this form where we have zeros, and then we can calculate how many moves it require for this bit to start flipping. Like for this it requires at least two moves, after which it will start flipping. So until two moves it won't flip. We can do directly by one, but to make it convenient and work for all strings, I just did one operation and I changed the total number of operations to k minus 1. So we'll be seeing that in the code. So yeah, here we are doing one operation, so that every string becomes in the form where there are no subsets of 1. Like we're doing one operation so that our string gets fixed. By fixed, what I mean is if the string is of type this, it will become in the form of this. If the string is of type this, it will become in the form of this. So it won't have two ones in matlab consecutively adjacent ones. It don't, so that it won't have two adjacent ones. Like if you do one operation, adjacent ones will be removed, which will help us in calculating the answer. So here we did one operation, and after doing one operation according to the given instructions, we did k minus minus, which mean that we will have to do k minus 1 operations. Now what we are doing is we are checking if si is double equals to 1. So if si is double equals to 1, it will start flipping from the very next move, because 1 don't have a neighboring 1, and what it means is 1 will have a neighboring 0. So we just saw that 1 and 0 will start flipping. So we'll set vi is equals to 0. Vi is the minimum number of moves after which a bit will start flipping, and front is the index of 1. Now if the character is not 1, then we'll check what is the distance of that character from front. Front is the position of last 1, and we'll store it in vi. Similar thing we'll do when you are running the loop from n minus 1 to 0. This we are doing that so that we get the minimum distance of 0 from a 1. After that we are checking the distance. Here we are calculating the final answer here. So in this we are just calculating the distance. Distance is how many number of moves are required for a bit to start flipping. uh, Actually the distance is not exactly like the how many number of moves. It is what will be the result if, like, vi is the number of moves after which a bit will start flipping. So if we have k total number of moves and the bit starts flipping after vi number of moves, The distance is the number of moves left. So if the number of moves left is modulus 2 is not equals to 0 is it, which means if the number of moves left is odd, then any bit will flip in the final answer. But if it's like even, like if we flip the bit 1 2 times, it becomes 1 again, and if we flip the bit 0 2 times, it becomes 0 again. So if the number of left moves is odd, then bit will flip, otherwise it won't flip. So but there is one more catch, that what if vi is greater than k, which means that if we want, suppose, 10 number of moves to flip a bit, मतलब to make it start flipping every move, but we have only 5 moves in total, like k is equals to 5, that bit won't flip. So if distance is greater than 0, left that bit untouched. In that way we get our answer, and finally we print the yes. Thank you.